Hey everyone, what we're going to do here is a classic optimization problem where we find the points on an ellipse that are farthest away from another point. Actually, the other points on the ellipse too. What's really good about this problem is that we can also review the topic just a little bit of the graph of an ellipse. So an ellipse can be thought of as an elongated circle. See what we have if if I were to have no 4 there for our ellipse, and this is x squared plus y squared equals 4, that would be a circle. X squared plus y squared equals 2 squared is a circle. But by multiplying x by a number, this stretches out the circle and it makes an ellipse. Actually, it's technically a circle is a type of ellipse. So to plot the point for our ellipse, or to sketch the ellipse, I'm going to plot points. And what I'm going to do is find the x and y intercepts. So when x equals 0, I just put in x equals 0, find y. So when x equals 0, I get 4 squared plus y squared equals 4. So y squared equals 4 means that y is equal to plus or minus the square root of 4, which is plus or minus the square root of 4, which is 2. And so I get the points 0, 2, 0, negative 2. And by the way, this is not at all a full explanation, even close to how to sketch an ellipse. But if you know it's an elongated circle, this will, I think, sort of do the job to some extent for our purposes. In fact, you could probably just do the whole problem without sketching this. But I think it's good because it's not even that hard to plot these points. It's sort of easy. If it were something really difficult, I just maybe find out another way so I didn't have to do that. All right, so what I did is I put in y as 0, and I got 4x squared equals 4. And so x is plus or minus 1. So you can maybe just do this in your head. You put y as 0 and you just disappear, and you see x is plus or minus 1. So we have the points 1, 0, negative 1, 0. And so with the aid of this iPad program here, I can see if I can sketch that ellipse a bit. Okay, so I have this point here is 1, 0, and then I have negative 1, 0. Now, 1, 0 is the point that's given that we're given the point 1, 0, and we're trying to find points on the graph that are, what does it say, closest or farthest? Actually, let me look at it. I think it's farthest. So, okay, it's not going to be the point across. I mean, so it isn't. You can just sort of look at it. And it's not going to be either of those intercepts that we just discovered. There's going to be the points, and it turns out they're going to be around here and here. We're going to just, find using calculus exactly what those points are. But there's 2 points. I'm just going to label one of those points x, y, and then the length of that line segment is d. That's my choice, is to call d. Of course, I'm just following what the book says. Okay, so what we're going to do then is we're going to write down the distance formula. That's pretty often given in an algebra book as d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. I am going to square both sides to make the problem easier. I need to sort of getting cramped there. Okay. I'm going to square both sides to make the problem easier, and I have d squared equals x minus x1 minus x2 squared. But actually, just to make that formula easier, I like to write x minus x2 as delta x, y1 minus y2 is delta y. Anyway, that's the way I like to write the distance formula often. Then I have these 2 points, 1, 0, and x, y. The other points, in fact, might be distracting that I have negative 1, 0 there. So I just want to focus on those 2 points that I just circled. Maybe instead of circling, I will highlight them. All right, so d squared is equal to x minus 1. That's the difference in those two x coordinates. And then I have y minus 0. And this problem, I mean, if it weren't 1, 0, if it were another point on the curve, then we could still proceed and do the problem, but you might end up with an equation after you take the derivative. It's difficult to solve without using a computer or something, but I'll show you what I mean by that. Okay, but let's just not go off on that sidetrack. So we're going to eliminate one of our variables, and I'm going to just warn you that it could be that say I've done a problem that's very similar to this. Say I do a problem similar to this where you eliminate x, you solve for x and get rid of x. That might be good for that problem, but I need to look at this problem, look at each one separately and figure out what to do. In this problem, we have 4x squared plus y squared equals 4. This is our constraint. That's the constraint is that the point xy has to lie on the ellipse. And this is the equation for our ellipse. Now notice I have y squared in my formula above that I'm highlighting, and I have y squared down here. It becomes very natural to solve for y squared and eliminate y squared. It is way less natural to solve for x, where I'd have to take a square root. So I might come to the next problem where it's better to eliminate x. So look at the problem and see which one is the more natural one to eliminate, x or y. Sometimes it makes no difference at all. But here's y squared again, and I just solve for y squared as 4 minus 4x squared. I didn't have to take a square root because it has y squared right there. So now I'm going to call this d squared f of x. By the way, this is a quadratic. Okay, what we're doing here is we're trying to find x. We're trying to find x and y. We're going to try to find xy that makes d squared a minimum value. That's the same xy that makes d a minimum value. But since I've eliminated y squared, I now am finding just x that makes d squared a minimum value. Since this is a quadratic, and it's facing up, it has a minimum at vertex. So you can just find the vertex, the first coordinate of the vertex. That'll give you your minimum. But we'll use calculus, so we're going to find critical points. What I was saying is, because someone left a comment on a video that was similar to this, if it weren't this point 1, 0, if it were another point, yeah, you get down to here, and you can take the derivative, but you might get it might be hard to find the critical points. But anyway, let's go and find the critical points. The derivative is f prime of x equals what? So I have x minus 1 squared. We use the chain rule. It's 2 x minus 1 to the first power. Take the derivative of x minus 1, and I get 1. Plus, derivative 4 is 0. Derivative negative 4. The derivative of 4 is 0. The derivative of negative 4x squared is, yeah, exactly. It's going to have, we still have negative 4. And the derivative of x squared is 2x. Someone said that becomes negative 8x. So let's multiply this through. This is 2x minus 1. Like this one sort of having it there, it sort of looks sort of confusing. Oh yeah, did it wrong. That's often. Thank you so much. Okay, so 2x minus 2 minus 8x, and we're going to set that equals 0. So we have negative 6x minus 2, and then we solve. That's like, why? I mean, doing all this calculus, and I forget to multiply the negative 1 by 2. Like, why does that happen? Oh, gosh. Negative 6x equals 2. X equals 2 over negative 6, which is negative 1/3. So what I'm saying is if we didn't have this sort of easier point 1, 0, if we had a different point, this, you can take the derivative, but you might end up with a function for which it's difficult to find the zeros. You know, you have to set this equal to 0. I think you might end up with a 4th degree polynomial, in fact. But I don't know. Or no, 3rd degree probably. Okay, so anyway, that's something else though. So now we're going to solve for y. And by the way, we can check on our picture. Does x equal -3rd, 1/3 make sense? I think it sounds reasonable. Notice that the minimum, the very least, x can be as -1. We could not have an answer of x equals -2. It doesn't even lie on the curve. And I would say it seems like it has to be negative. So -1/3 is not what I've drawn here. In fact, why don't I, now that I know that answer, why don't I improve upon my drawing? It's going to be like more up here. But that sounds reasonable. I, for whatever reason, by eyeballing it, did not pick -1/3. So, but maybe a lot of you would have. You would have said, oh yeah, it seems like it has to be up there or something. Okay, and so now we're going to find y, and we can see that we should have 2 values for y. Let's keep that in mind as we find y. All right, so we're going to solve for y, and the way we do that is we're going to use the 4x squared plus y squared equals 4. So I'm going to put in for x squared -1/3. Unfortunately, this sometimes ends up being one of the more difficult parts, but I don't know, depending. Okay, so y squared is going to be 4 minus 4 times 1/9, so -4/9. So y squared equals 4, but I need a common denominator. I'm going to write it as 36/9, because if I multiply 9 times 4, I get 36, and the denominator 9. So, so y squared is 32/9. But by the way, as we know, knowing our times tables, or maybe, anyway, whatever, 32 is 2 times 16. And I want to know that because I'm going to take the square root. So I have plus or minus the square root of 2 times 16/9. Square root of 16 is 4, square root of 9 is 3, and we have radical 2. So we get the points x is -1/3, y is plus or minus 4/3 rad 2. I'll just write them as 2 separate points, as you know, as that's what they are. And that seems to make sense. We could try to fiddle around to prove that this number is between 0 and 2, because it has to be between 0 and 2. I guess if you, okay. I mean, if you square it, this is less than 2 squared, which is 4, so that makes sense. Okay, so this is our answer.
Your second point is over 3.
Oh, gosh, thank you, because that would be, like, ruin the whole video if I ended like that. Thank you really a lot. Okay, so, and we can go back and look at our picture, like, copy it down, paste it one more time.
Wait. Can you zoom in at the bottom?
Well, let me just, okay, yeah, I'll zoom back out so if someone wanted to finally take a screenshot at the very end, but yeah, go ahead. After this, we're going to look at, I actually just end the video, right? Okay, yeah. That was like no reason to keep that going. That's sort of weird. Okay, so we're going to end the video, and I'll just keep this up here. Okay, so that's all. All right, take care. Like, comment, subscribe. Thank you. Bye.